All right, everyone, it is the top of the hour, so we will get started. I want to welcome everyone to our NAGT webinar. The NAGT webinar series is your one-stop shop for strengthening work in Earth education. Webinars in our series feature novel and innovative work in Earth education, research, pedagogy, new teaching materials, and the classroom and professional experiences of people like you. Our webinar series is free and open to the public, so we encourage you to invite your colleagues to attend and join the discussion. In the chat is a link to our webinar series homepage where you can find the webinar schedule, an archive of past events, and information on our sponsoring projects and programs. You can find the slides, resources, and recordings of all of our webinars, including today's, through the webinar archives. A quick reminder that participants in all our NAGT meetings and events are expected to abide by the NAGT Code of Conduct, which applies in all venues, events, and online forums associated with NAGT. So please read the full NAGT Code of Conduct policy, which is also in the chat for details if you haven't already seen it or are not familiar with what that looks like. Today's webinar is called Sharing Scientific Ocean Drilling with Students, presented by Laura Gerton and her colleagues aboard the JOIDES Resolution. If you guys have questions and comments throughout the presentation, we encourage you to enter those into the chat box. I will be helping monitor the chat, and there'll be lots of pauses during the presentation where we can interrupt and interject those questions, and there'll also be time for questions at the end. So with that, I will hand it over to Laura.
Hi, everyone. I'm Laura Gerton. I am here connecting to you live from the JOIDES Resolution in the South Atlantic Ocean. And today I am going to be taking you on a virtual tour. So it's a little different type of webinar we've got going on. I'll be talking a little bit about what we're doing on this particular expedition on the JR, talk about the scientific objectives. We'll go around, we'll meet a couple of people. And throughout the tour, I'm going to be inserting a little bit about how a tour of your class with the JR at any point now or in the future is a really nice way to actually bring in a little bit more information about who scientists are, the process of science, and also why it matters for us to be able to do this type of work. So just a quick note, because I am on a ship in the ocean, that the internet may bounce in and out a little bit. I've been pretty fortunate with that. So I am going to ask if you have your video camera on to turn that off, just because it actually helps with bandwidth issues a little, I have found. And then what we're going to do is, again, go around going over some great stuff. And I'm going to start with how I would start with any classroom that I join with. So as a professor of earth science at Penn State Brandywine, located right outside of media, I'm very comfortable speaking in front of classrooms of students. I've taught online. This is a whole nother way. So what I try to do is step back a little bit and paint the bigger picture before I narrow down into what scientific ocean drilling is. So I always like to start with a visual with my classes. And so hopefully you can see this one too. And I remind students that when you think back to when did you first see an image of Earth? Yeah, when did you first see a globe, or what was the first map that you saw? It probably looks something like this, where you have all these colors on it, but each color represents a different nation. So when we're first introduced to how to look at Earth, we're actually introduced to the political geography, right? So these boundaries that are broken up by governments or culture, et cetera. One thing I do like about this representation, though, is that you have one color of blue for all of the ocean. And yes, we have one ocean on our planet, covers 71% of our planet, but there's so little we know about it. So scientists estimate it's only about 20% of our ocean that we actually have explored and discovered. So one of the reasons we're here on this ship is to try to get some more of that information. And also while we're here, I try to talk about the bigger picture as well too. I like to bring in Earth system science as well. So talking about atmosphere, hydrosphere, biosphere, lithosphere. I don't need to break that down for this group here, but even though we are on the ocean, it's part of the entire system of planet Earth. So yes, we're actually here looking at collecting sediments and basement material from the deep sea, but all of these combined, right? So lithosphere for our basaltic crust that we're drilling through. You've got your biosphere, the living component is part of this expedition too, and I'll share that in a sec. Atmosphere, we'll have those interactions spent over time. What can we learn from this expedition to help us understand what's going on with climate changes and how that might impact the ocean? So all of these together, keeping again that kind of bigger picture in mind as we then narrow down and start talking about what's happening on the expedition. So where I am is JOIDES Resolution. So yes, this is my high tech my high tech board that I've got here, but it works well. So most of our students have only seen a picture in their textbooks of Glomar Challenger and JOIDES Resolution. Those are the two scientific ocean drilling ships, starting with Glomar Challenger back in 1968, which was then retired and replaced by this current vessel, JOIDES Resolution. These are the two ships and that have, through the United States, actually gone out and collected cores. They've gone through sediment, they've gone through the basalt and brought that deep sea material back up to us so that we can do research on it. So each expedition of JOIDES Resolution goes out for 2 months at a time. And during that 2-month period, there is particular objectives that you have. This expedition that I'm on right now is actually half of what we would say is a double expedition. So I am on the ship for the first 2 months, then we return to port, and then a fresh group of scientists and crew come on and finish this expedition. It's a long one. We started in Cape Town, South Africa, and we departed on April 12th, and we headed west. We headed from Cape Town going towards South America. We went across the Mid-Atlantic Ridge. And what we're doing is we are collecting material, we're collecting cores in a transect that is perpendicular to the divergent boundary. So pretend the ridge is coming in and out of the board. We are collecting cores in an age transect, which is great. We are going through that sediment package. We're going through that basalt that's underneath. And for my ship, it took us about 9 days to get to the first site. And this is where we just finished up collecting the last of our basement material from the oldest core. And one of the things we're trying to look at is going beyond what we know happens to the rocks at these ridges. So we know you've got the youngest material when it first erupts, and your rocks get older as you move further away. So we understand just basically what happens, that it gets older. What we're still trying to wrap our heads around is what happens to those rocks though. What are the chemical changes that occurs? What are the physical changes that occurs? What's the impact of the fluids, those hydrothermal fluids or any of the fluids that are moving through the sediment and the rock? What's the impact of that fluid flow on changing the chemical and physical properties? So this is one thing we're trying to take a look at. We actually, in this oldest core material, we went back 61 million years. So not quite dinosaur time, but we've got some great material that's going back in time to help us understand what's going on with this age transect. So that's one of our main objectives, is to understand the aging process. We know, again, it gets older, but what happens to the basalt during that aging process? The other thing we're also interested in looking at is the microbiology here. So this is an exciting component of this expedition. What is the life that is living in these sediments and rocks, and how do the life assemblages change with time? So what's happening with diversity of the microscopic life that's in here too? So this is an exciting addition for this expedition. And we do have microbiologists on board with the geologists. And one of the ways I explain this to students as to why we're interested in tiny life forms deep in the ocean that may not impact them, well, there's organizations like NASA that are trying to find life on other planets right now. And we know it's not going to be a humanoid life form that they're looking for. They're looking for really small life forms in the oceans on other worlds. And so when we think about planetary analogs and how do we understand what's going on other planets and how do we direct our explorations, we have to understand our own planet first and how things form and function here on Earth. So to help students understand maybe a little bit of a bigger picture as to who cares and why this matters, that's one way to really think about why we can get so much information that's so useful for us. So what I'm going to do right now is I am going to put my inflatable globe away so that it doesn't roll around while I start walking around the ship. If anyone has any questions they want to type into the chat, go right ahead. Then I'll be right back with my hard hat and let's go start seeing the ship. Okay. Anything come in, Bradley?
Nope, you're all good.
All right, so what I'm gonna do is reverse the camera here, start walking. We are on the bridge level. We are on the upper level of the ship. I like to start here at this map. This is a map that has a lot of tiny dots on it. Each of those dots represents an area where we have had scientific ocean drilling go on. So each of the dots represents where we've had material that's been collected. And you'll see in the Pacific Ocean, we actually have a lot of dots here. In the North Atlantic Ocean, we have a fair number of dots there too. South Atlantic, not so much. It's pretty sparse. And so this expedition, we are in this region here, where you see these pink dots that are in the middle. And this region is actually pretty significant when we think back to kind of the early days of plate tectonics. I mentioned Glomar Challenger being the original scientific ocean drilling ship from the United States. It started sailing in 1968, and its third expedition, so the third time it went out, it came to this same area. And what it did was it did some spot coring, and it collected the material that helped us understand seafloor spreading and gave us that physical evidence we needed to prove the theory of plate tectonics. That was 50 plus years ago. So here we are, fast forward, we're revisiting the same area, but of course we've got much more sophisticated questions, right? We've got questions that they never would have thought to ask on Glomar. So we're very excited. Again, this expedition started in Cape Town, came out here. We're going to be collecting a couple of those cores, but then we're going to have to go back. I'll be back in port on June 7th. And then the next group comes on, and then they come out and finish the coring there. So I think it's going to be really exciting to see what results we can actually get out of revisiting a site. So to be a part of what we're calling a legacy expedition is really fun. So what we're going to do now is go and see what you all came for, which is the ocean. Everyone, I wish I had some sunshine to show you. Maybe you could send some my way. We've had some really cloudy days. The weather has been hit and miss for us. Sometimes we've had some incredible waves, and then we've had the heave of the ship. Heave is when the ship is moving up and down on the water. The heave has been as high as 12 feet or 17 feet on some days. That puts a little wrinkle in our drilling activities. But we are currently on site again at our first drill site. We're running the last of the wireline logs to be able to move to our next site. How we stay in one position is something called dynamic positioning. Underneath the ship are 12 thrusters that are all connected, wired together, and they communicate with each other. We tell the thrusters where we want to be in terms of latitude and longitude so we can stay in one place. And they know to actually then fire off. They don't fire any sound, but the engines get turned on, and then they keep us fairly well positioned. Out here, as you can see, lots of water. We haven't seen too much wildlife, although we did have a couple of whales this morning that were off the bow, a whale a couple of days ago. When we left Cape Town, we saw a humpback whale. There were penguins that were there, mola fish. And even though we're a ship filled primarily with geologists, we're all geeking out. Every time someone says whale, everyone just leaves the science lab and runs outside so they can actually see what there is. When all the educators on board. So my official position on the ship is I'm an education outreach officer. So JOIDES Resolution has 60 scientists and science technicians that are on board for each expedition. That's half of the contingent on the ship. So the ship will usually have a maximum of 120 people. Half of them are scientists and technicians, but they do have 1 or 2 educators on board. And so this is a position that you can apply to come on for 2 months, and part of your duties are running tours of the ship. You run the social media, you do blogging, and it's a lot of fun to be able to do that. One thing I do on all my tours is I stop at this, which is, I know is not very scenic, you'd rather see the ocean, but my own students have asked a lot, well, to do oceanography, is it safe? Do you need to know how to swim? So please don't underestimate how concerned some students are that have very little experience near the ocean and only see about the ocean in Hollywood films and TV shows. So I always talk about safety. And so this is one of our lifeboats. We have 4 lifeboats on the ship, and every week we do some sort of emergency drill. It's abandoned ship, or there's a fire, or man overboard, or something like that. So we're always testing detectors on the ship and going through drills. So what's nice about these lifeboats is we've got 4 of them that hold 70 people each, so there's duplicate. So there's more than enough room for everyone. And they are completely enclosed because JOIDES Resolution sails in every ocean. So because it goes in every ocean, the waters can be pretty rough, they can be pretty cold, but the lifeboats can keep you protected. So I just mentioned that because some of our students are concerned about going into different fields because they haven't had experience being on the water. So this is a nice thing to be able to show them. I apologize, my conversations will be a little short as I'm walking because the ship is bouncing up and down and I'm trying to walk and hold a tripod and an iPad. That is a new skill I think I will be listing. We're just gonna go look off the bow of the ship briefly, see if we see anything out here. Oh, we have a lot of wind again today. Oh, cargo ships, I should have mentioned. That's the other thing we've seen on the water is cargo ships. And we, in the beginning of the expedition, we're yelling at the cargo ship, stay away. We were in our pandemic quarantine period. You notice I wasn't wearing a mask, only because we've been out here for 2 weeks. We have gone through 16 COVID tests to make sure that we don't have COVID on the ship. The last thing you want is the COVID outbreak out here. We're feeling pretty good. Everyone has tested negative on the ship for the entire first 2 weeks. So we are mask free. And we're going to step into this area now. One part I like to bring on the tours. Okay, welcome to the bridge of the ship. So if this was a younger grade that I was taking around, I would say, ooh, what's here? Where do you think we are? And I'd say some goofy things to the captain, but I'm not going to do that to him today. But he is here joining us. So I thought I'd introduce all of you. Here we got Captain Robinson here, who is the one that's taking care of all of us and controlling the ship. So Captain Robinson, thank you for your time today.
No problem.
I know it's after your shift too, and you're staying later to talk to everyone. So I planted him with a couple of questions. So we'll see if he did his homework and he's ready. I was wondering, because one of the things we like to try to have students understand is careers and what's out there, and that you don't always know when you're an undergraduate student even where you're going to be going. So could you share with us just a little bit of how you got to be captain of JOIDES Resolution?
Sure.
Can you hear him okay too? I'm sorry, you should probably talk more before I say that, right?
Can everyone hear me? So kind of going back to high school, yeah, I wasn't really interested too much in high school until my dad bought a sailboat. And then just sort of by happenstance, one night my dad brought home some charts and he and I started a conversation. And the idea of sailing for a living was something I was interested in. And as luck would have it, a couple weeks later, there was someone from the California Maritime Academy at my high school sort of talking to people. And I kind of went from there. So I ended up going to the California Maritime Academy. And out of there, I was recruited to go work in the oil field in the Gulf of Mexico for a while. And I've had enough of that. I was looking to get out of it. The company I worked for at the time, they owned this ship. And so I put in the transfer and just kind of luckily got it. That was, I came out here as third mate back in 1998. I ended up working out here as third mate, second mate, and for a short time as chief mate before I decided to go back to shore. And I ended up going to law school.
If they're wondering if you could speak up a little bit.
Sure.
Sorry.
So yeah, after working out here for about 5.5 years, when I was younger, I quit and went to law school in New Orleans to do maritime law. I practiced maritime law for about 3 years up in Portland, Oregon. And so the world economy hit the skids, shipping was down, and so work was down at the office. I was looking to get, looking to go back offshore. I ended up calling up my old manager, letting him know that I was looking for a job and just asking for just sort of a letter saying I was an okay guy. And then he told me my old job was coming up. If I wanted it, I could have it. So I ended up coming back out here and just kind of stayed in the position. I was excited to get back. I really enjoyed this job. I really enjoyed working on the ship. As it worked out, the timing was right. The moved back up to chief mate for quite a while. And then when the captain's position came open, I was in line and happy to take it. That's how I got it.
And that's important for the students in our intro classes to know. So they might be taking our classes for a science credit, but maybe don't want to become a scientist, but there's lots of other positions and roles that actually can support scientific research.
Yeah, and it's one of the things we've talked about on here with some of the other sort of tours and having classroom discussions was all the different jobs and positions available on a ship, and sort of all the different types of work that are done on board.
So in terms of the ship, so you're the captain of JOIDES Resolution. I don't know if you realize how significant that is in our discipline, and what role you play in us being able to accomplish our science. But so why do you think it's important for students in our classrooms to know about this ship and what we do?
For a number of reasons. One, just as we talked about, sort of the number of different trades and professions that are available. And so that can speak to a lot of children who may not know what they want to do in life, or at least show them sort of where other opportunities lie outside the community. But then also just the science aspect of it, and sort of the mission of the vessel and how that has affected life generally, sort of what's been discovered. Sometimes it's really interesting to talk about the things that have been found from the samples we've taken on board. And it's always kind of fun to sort of spread the word about those things.
Great. Any questions for Captain Robinson before we continue on? So the educator position, Kim, I see your question. It's been around for a number of years now. I don't know exactly when the first expedition was that they brought educators on board. She sailed in '86, and I guess there weren't educators then. No questions in the chat, at least I don't see any.
There
So
is
Captain
one
Robinson,
other
I'm gonna take-
question about
Sorry,
when are
go
hard
ahead.
caps required?
What was the question?
When are hard hats required?
When
When are hard hats required?
because I'm wearing one.
Yeah. Pretty much in all the workspaces. And we've got those marked on the deck. If you go too far aft, then you're sort of in the danger zone from anything falling off of the derrick. But the entire main deck, you've got the drill floor work going on. You've also got crane operations that could be going on at any time. Then in all the machinery spaces and work areas, hard hats are required.
So the only reason I have it on is because I can't carry a hard hat and an iPad at the same time. So that's why I'm wearing it throughout the whole tour. All right. How long are the shifts?
12 hours. We all work 12 hours on, 12 hours.
So my shift is 12 p.m. to 12 midnight. And so then I rotate off with someone else that does education and outreach from 12 midnight to 12 noon. So it's 12 hours on, 12 hours off, 7 days a week for the entire 60 days that we're out here.
And then I'm available 24 hours a day.
That's why he's doing tours after his shift. All right, I'm going to go ahead and continue on. Thank you for your time
Sure.
today, though. Really appreciate it, Captain Robinson.
Enjoy the tour.
All right, let's go ahead and see some more, and then we'll get down to the science labs. Okay. 12 hours off for 60 days is because when you think about it, what else are you going to do when you're out here? There's no place to go, nothing to see. We're going to be now walking towards the center part of the ship. We're going to be going towards the drilling derrick. So we'll just get a little closer and see what we can fit in with that. This part of the tour, I also talk a little bit about life on the ship for students, the 12 hours on, 12 hours off, how on the ship, and then the ship itself, the length of the ship is actually about 427 feet, which is the length of 5 basketball courts. That derrick that I just showed you, the derrick is about the height of 20 basketball hoops. And right now I'm using basketball as a lot of my references because it is the NBA playoffs and I live right outside of Philadelphia. So I'm rooting for the Philadelphia 76ers, but I cannot watch any of the playoff games. We do not have television on the ship. So there's no live streaming of anything. So there's no Netflix, there's no YouTube. And when students hear there's no cell phone service, some of them say, that's it, I'm out of here. But we do have an incredible movie library on the ship for people to check out movies, because we have a movie room, we have an exercise room. So there are ways for us to relax as well. So we are currently not drilling any core because, as I mentioned at the beginning, we did finish up, but we are going to go towards this area, and then we'll head down to the science lab where we've got a scientist that's waiting to chat with us. So as I mentioned, this ship we have 113 people on this particular expedition. So we've got the bridge, so the captain and his group that are helping with navigation, tracking the weather, which is really important too. Then we've got our people that are working on the rig floor, that are always, they're busy. Again, this ship runs 24/7. So they're always doing something down here, either adding new pipe and going down or bringing core up. I'll just move into another side here. It's pretty exciting when during the tours that core actually comes up. And so it's really fun to be able to see for the first time, along with all the scientists, what they're bringing up from depth. Towards the very, very, very back of the ship, you might have seen it from the image. We do have a helipad on the ship for emergencies. We're actually too far out in the ocean for a helicopter to come rescue us at the moment. So it's being used for exercise more than anything. I'm gonna go to an area that's a little more quiet so I can keep talking. You'll see that pipe is coming up. When we finished at this particular hole, we actually dropped the drill bit. That is not uncommon to do at a particular expedition. So what we have to do is get a new drill bit on the bottom. These drill bits, here's what they look like. Which drill bit you use depends on the material that you're actually pouring through and you're trying to collect. So you'll notice some of them look much better than others. Typically a drill bit, currently they're lasting about 61 hours of drilling. So again, flip these guys upside down and we spin them on to the bottom of the pipe and they go to work for us. Depending on the depth of the water will dictate how long it takes us to go down, collect the material, and then bring it back up. So we'll typically drill for 9.5 meter segments of material. Once it comes up into this area that we call the catwalk, and then the outside of the material of the pipe is then wiped down. It is capped and it's brought inside of the science lab. For those of you that have been on the JR, I know I'm really glossing over these points, but I want you to be able to meet some people and ask some questions. And welcome to the core lab. So this level on the ship is where we've got all our scientists except for our geochemists and microbiologists. They're one floor down, but we've got everyone else here that's, as soon as the core comes in, is working together to do all sorts of analyses. So I'm just gonna briefly jump into this space on the side because it's another space where I like to talk about careers on the ship too. So we actually cannot run out to Lowe's and Home Depot if we find that we need something. We can't call Best Buy Geek Squad if we have a computer issue. So on the ship, we also have computer programmers. We have IT people. So we have people that are so clever and creative and innovative. And it actually helps us repurpose a lot of material that we have here to find solutions if there's any challenges that come up. So what you're looking at here, this is some of the split core. I came up not that long ago. And yes, it is basalt. So we've got a lot of that. I'll just pause over it briefly, since we're geoscientists and we love to look at rocks. But it is pretty amazing to be able to look at this material and see some of the first material come up from these holes. I'm just going to go down briefly. We've got some volcanic glass that's mixed in with here too. So our petrologists are having fun describing. And brecciated material, yes, Karen, there is brecciated material that's within here as well. So pretty amazing. Let me see, I think it might be better over here.
How much
How's
core
that
was
for
brought up
cooling?
at the first site?
I'm sorry,
How much core was brought up at the first site?
how much? So we went down to just over 600 meters in depth. So, and that was our sediment package as well as the basalt that's in there. So going down about 600 meters and again, going back about 61 million years. So there's a lot of core, and that core actually gets split into half. We have what we call our working half and our archive half. So on the working half, well, we start working on it. We start collecting samples. We do all sorts of analysis for physical properties. We describe the sediments. We do micropaleo. If it's sediment as well, we have a foram person and a nanofossil person on the ship that try to do that. We have a magnetometer on the ship, so we can actually do some paleomagnetic analysis, and we use the micropaleo with the paleomag to be able to construct our age model. That's within there too. So we've got, this is just our core splitting laboratory over here, but the person I really want us to go meet and see is Justin. Justin is an instructor at Maine Maritime Academy and one of our physical property specialists. We have 4 of them on board. Hi, Justin.
Hello there.
So welcome. This is NAGT.
Oh, hey, how's it going?
And so Justin's going to tell us a little bit about what he does with physical properties and then a little bit about his background too in thinking about careers. So I'm going to detach the iPad here because it's easier for me to work with you.
Got it. You want me to lean this up for a second?
Yeah, let's just lean
Let's lean it up right here.
it. Okay, that sounds good.
Hide it in our apparatus here. Maybe not. I'll put a quarter behind you. Yeah, I was just cleaning up my mess where I was being talked with earlier.
All right, Justin, what is it you do on the ship here?
So yeah, like Laura said, I am in the physical properties team. So we are measuring the physical properties of the material, all the samples that we pull up, either from the cores when they come up in a whole round. We're measuring physical properties from there. Physical properties could be the density of the material or the velocity that seismic waves move through them, what kind of magnetic susceptibility exists in the material, what kind of gamma radiation is emitting from the material. Very, very low degrees, very, very low concentrations of gamma ray radiation, but it's still present in natural materials. And we can measure that for ideas about what type of lithology we get or our samples are. And we do that in the whole round stuff, but then eventually cores get cut and they get chopped up into pieces and we actually collect. We're still measuring physical properties on little samples. So these little cubes here, we can actually get, it's a much finer, much more discrete measurement, but we can get a much more precise measurement on these cubes here. And we orient them. If you see the little, that one's washed off a little bit, but the red arrow is kind of pointing up. So we know that that is the up direction in the core. So this was sitting in the earth like this. So we can get different axes here and measure, does velocity move through it this way, faster than this way, faster than that way, to tell something about mineral or grain orientation. And we're also, something that's very important, and I think the measurement that I collect that everybody likes the most is porosity, because porosity is where water can exist. And I measure these wet and dry, whether they're saturated in water. When they're saturated in water, they're full, all the pore space is full of water, and then I bake them in the oven for 24 hours and measure them dry again, and however much mass loss we assume is mass loss from water, and that gives us an estimate of porosity. And porosity being places where water can exist And as we all know, that water is like incredibly important for chemistry, for life. So a lot of people like my porosity measurements here on the boat.
Justin is a very popular person.
Yeah, that's the one. That measurement is very popular. I don't know how I am. Yeah, so Laura, do you want to see one go, or do you?
Sure,
like, I
if
don't know
you've
how
got
much
a
time.
chance.
I can absolutely go. This is a really cool one. This is the one. This is an AGT. I'll say one I like to show on the tours when there's students tuning in. I think this is fun because it's accessible. Measuring something on a boat, when we want to measure mass, like the mass of a dried cube, we can do that with a simple balance, but we have the extra trick of the balance is going up and down with the motion of the boat. So we have two balances, and in one balance, we put our sample. I'm going to get the drawer right beside you. And in our other balance, to correct for motion of the boat, is we have these known, these are reference standard. So we have like known mass. So this is 20 grams. And if I put this in the other balance, I know what I'm measuring. So now I'm measuring an unknown and a known at the same time. And these balances that measure mass, and mass is important for almost everything that we do out here, they go up and down. And I think students actually like to see this part too. So I'm going to find a sample here where I'm going to measure this.
So I like bringing this part into the tour when we talk about the process of science a little bit and how we do science on a moving ship that's on the water. This is something that students aren't aware of. And so with the adjustments or how we need to put in some extra steps into how we take our measurements, because again, we're at sea.
This one's fun. Okay, so now I'm going to tell it 20 grams, and I'm going to hit weigh. Oh, it must tear. Okay, you'll still see the same effect. I should have teared beforehand. You'll still see the same effect, but what you'll see is okay. Down there. Yeah, you see the two curves? One curve, these curves, both red and green, are showing the motion of the boat. What you're seeing is the balance of the scale go up and down. And here on the y-axis is the mass that it's measuring. So one of these, the unknown mass in red, is going up and down, just like the known mass of 20 grams is going up and down. And what that allows us to do is actually correct for the motion of the boat when we measure mass. So I really like to show this one because it's fun. There's like a graphical representation of what's happening. If people think of like, well, they know measuring mass, right? That's not something we do in science all the way from like middle school.
And someone mentioned, never thought about having to correct for ship motion on measurements.
Yeah, isn't that cool? It's super cool. So this is one I really like to show off.
So it's a short one, but it's, again, I think it's very easy for students to be able to say, oh yeah, hadn't thought of that, but yes, that's something that we need to do. And then I also like to stop by Justin here on the tour. Every person on this ship has a different story. Justin's origin story, I find really interesting and relevant to a lot of the schools I'm connecting with on the ship so far. So Justin, do you want to talk about kind of where you came from and how you got here?
Yeah, absolutely. I like it too because I like to, I really enjoyed the examples I had with the students, people I could relate to, I suppose. And I think that's something important for students. So my story is I was a non-traditional student. I went from high school and I got some technical certifications so I could go to work, and I was working in IT, in a low-level IT, and I realized I just wasn't satisfied with my job. It was an okay job, but I wanted to do more. So I went back to school, meaning I actually went to college this time, but I didn't. I was the first generation. Nobody in my family had been to college. So I didn't know really where to go. And I kind of just went to community college and started talking to people until I figured out where I needed to go to sign up so I could go to college. And then I found geology. I didn't really realize that that was even a science. Like I probably knew the word before going to college, but that's when I found geology. I was like, well, this is actually fantastic. I love doing this. And I probably need, just like many of us geologists, we just really like the earth. We love rocks. We like hiking, stuff like that. I was like, wow, I get to do stuff like this for a job. This is like what I get to do for a career. So I spent 2 years at that community college and got my degree there that then I could then transfer into a four-year university. And I never really had like a super laid out plan of how I was going to get where I was going. I just kept staying interested, and I ended up getting my PhD in geophysics, which I never would have imagined in the world, even when I was at this community college falling in love with geology. I never would have imagined that. And then now I'm a professor of oceanography, actually. And that's kind of my origin story of like just wandering into community college, finding something that I really, really, truly enjoyed doing, and something that I could be passionate about enough to stay in it until they just make me teach it. And I think that's really cool. Looking back, it's like I saw that transition from community college as a student to a big research university as an undergraduate to doing research as a PhD student at a really big university. And I think this is really cool. This would have been so cool as a community college student, getting to see this out here, getting to see people out at sea doing geology. Like that's where I picked my major. I knew when I was in community college that I wanted to do geology, but I was kind of imagining what it would be like. And I didn't get this kind of exposure because it wasn't a research institution where there's labs that you can wander into and see instruments that are measuring radioactivity, right? It was like, there were general chem labs and general physics labs, but this would have been so cool to see as a geology student at a community college, seeing people out at sea having to overcome the motion of the ship so we could just simply measure the mass of a little cube of rock.
So as you can see, why I include Justin on all my tours. And in fact, we've had a number of community colleges sign up for tours. And I always ask Justin, and he's always so gracious and giving his time and telling that story and the impact it can have on our students. Again, we're trying to get themselves to possibly see themselves as a scientist and being able to do this work. And so when Justin can say, hey, I was in your type of classroom, I was where you are now, it's just really amazing, the feedback we're getting from instructors on that. So just another example of where someone has come from and how they ended up on this ship. Someone actually typed, or they're typing, yay, community college, great educational pathway story. Sounds like a story for the GO2IC newsletter. Guess we'll have to follow up with you on that.
Oh, please do. I'm happy to. And if this is an AGT, so it's all a bunch of people that are very passionate about teaching geoscience, right?
Of course, of course.
I just want to say, I can't see you. I'm looking at the iPhone.
Sorry, yeah.
But I want to say thank you. Thank you for teaching the students. It's like fantastic. I had fantastic teachers. The only reason I'm here is because I had fantastic teachers that really cared about me as a student and the other students. And like that's what happens. Like people move on, they fall in love with it, and they get encouraged by fantastic mentors. So thank you.
So now you're the mentor for the next group.
I try to be. I really do. I try to emulate people that help me get here. So.
Oh, what a great tribute for Teacher Appreciation Week.
Yes, absolutely.
Thank you, Justin. So
Thank you.
we only have a few minutes left, so I want to at least take them around, just show them
please.
a little bit
Do you
more.
want me to help you with the tripod? Or
Can I just leave that there for the rest
you
of the
can
time?
leave it right there.
I'll come back and fetch it, I promise.
I might even weigh it.
So, okay. You need to tear the scale first, though.
I do need to tear this.
All right, so just to show you again, a little bit, this is part of the working area that we do some of our preparations. This is just some of the imaging equipment. Down at the end there is Kiho. Kiho is from Korea. He's one of our sedimentologists. So it looks like Pamela's done with her describing. She's one of our petrology people. We have a magnetometer here on board. Again, we're looking for magnetic inclination, those normal and reverse polarities within the samples that we collect to be able to know or contribute information for our age model. Jalma's down there working probably on some of that magnetic material right now. Jalma being from Italy, Claire all the way down on the end there. Claire's doing a postdoc in Germany right now, originally from New Zealand. You could see a gazillion microscopes here. Maybe not a gazillion, but we've got a lot of microscopes for using to describe thin sections. Claire's using it as our nanofossil person on this shift. She's again putting sediment material there that she can magnify 1,000 times to be able to determine what nanos are in those sediment packages that we actually pull up. And we've got more laboratories, more micropaleo prep areas. We have an XRD on board. We have a whole thin section room on board as well. So we make our thin sections on the ship. And there's some analyses that we just can't do on the ship. So I see there's some questions about some of the microbes that are there as well. So the ship is not a clean ship. We don't have a clean room on here. So what we do though is we do prepare the sample. So as soon as the core comes up, our microbiologists actually go in and collect that material. They bring it then downstairs to actually try to prep it, vacuum seal it, freeze it, so that those analyses can then be done back in a university laboratory or a research laboratory. So not everyone out here is a faculty member. Some people have research positions at different organizations too. So we've got a little of everything out here. Is all the instrumentation standard or does it change? It does change. Actually, this behind the curtain is one of the instruments that came on board. This is the first expedition using it. I'll pull back the curtain a little bit. It's a scanner. Thank you. And we're not using it at the moment, but what we do is there's 2 different rollers in here, and we'll put a section of core on here, and we've got a video camera. And so what that does is the core sample will slowly roll, and the video camera will actually then record all sides of it. And then we have this computer open, and what we're doing is creating a 360 scan of the outside of the core. So that way people have it back at their institutions to look at, and we're hoping maybe we can find a way to develop a computer program. One of our scientists is working on that now to see if that can help with the identification with the samples in there too. So it's pretty exciting for that part. I'm going to see if there's any other questions. So the instrumentation does change because it does depend upon what's happening. Not all the expeditions will have microbiology, so some of that instrumentation changes below. We anchor the instrumentation down pretty well too. Sometimes with bungee cord, sometimes it's bolted to the material because again, the ship can heave. And so we're very mindful of that as well. I'm trying to see if I missed any other questions here. We've got the age, brushing material. How do they find the hole and keep drilling? So we have something on the bottom that's called a re-entry cone. And that is something that is set up and it's got, let's see, I think I have to jump upstairs to show you that, but it's got almost black and white stripes that are concentric. And we send a video camera down with the pipe to actually help us find that on the ocean floor. And so that almost is like movie time for us on the ship. To look at that. So I'm going to jump up to the re-entry cone photo. Then I'm going to jump down to show you one more thing in the stairwell. The stairwell is a popular place on the ship, believe it or not. Got some interesting things to look at. Okay, back to my teaching board. Here we go. This is an example of what we set down on the floor. Again, how do we know where we are and what we're aiming for? It has the number of the particular hole that we're at. And then you see an example here of the drill pipe actually through that. So this is the moon pool. It kind of freaks students out sometimes to know there's a hole in the bottom of the ship. Why doesn't the ship flood with water? So we talk about that technology a little bit too, but this is the opening where not only the pipe goes down, but we'll actually put down that, that re-entry cone as well. And one more thing I want to show you, because something came up in a tour I did yesterday that I thought, again, when we're trying to introduce who does science and our science identities. So we've got people like Justin, which was great. We had the captain that spoke to us. When you're out here for 60 days, of course, you're away from family and friends. We have email. Everyone's allowed to do one 15-minute Zoom call, personal Zoom call a week. So we sign up for that so we can contact home. We have no animals on the ship beyond those microbes, of course, but we have a pet wall. And so people will actually put up photos of their cat, dogs, fish, what have you. And so we kind of share that with each other. And the other part of the stairwell is just kind of legendary on the JR. Every expedition, there's a contest. So we have the official logo for the expedition, but then there's also a contest for people to draw a logo for their expedition. They get screen printed on t-shirts that everyone brings home. So I'll just show you a little bit some of the logos here. Clever with penguins, some with dinosaurs. And the logos go all the way back to Glomar Challenger days. So all the way down in the stairwell, we've got these expedition, these contest patches that are all the way in the ship. At the end of one of my tours, a student in the audience actually asked, she's like, I don't believe scientists drew that. She said, all my friends are scientists and none of them have any artistic talent. You must have an artist on board that drew those patches. And that made me laugh a little. And I said, well, just so you know, when I was your age and I was an undergraduate student sitting in a geology classroom, I also played in my college orchestra. And currently I'm a crocheter and quilter. I said, I bet your instructor has a life outside the geology classroom too. So that's another important point and a reminder for us to show students, right? We have these multiple sides to ourselves. We're not just science all the time. Now on a ship, it definitely feels like that because we're out here on the water, but yeah, just again, an incredible opportunity doing these tours. And then there's information as well. So on the lecture page, again, while I'm out here on blogging, so there's information students can tap into, learn more about what's going on with the expedition. There is also what's called the family and friends photo. So during every expedition, every week, there are photos posted online, a photo gallery with descriptions of everything from the birthdays that we've celebrated on board to samples that have been collected in the lab. So I'll just pop into one of the laboratories here, our geochemistry area. So we do have some fun on board too. So you get very close with this incredible international community. It was also a great opportunity for me to discuss with one of the schools why group work is important. Students, not all students are fans of group work, but my goodness, you absolutely need to know how to work with people when you're close on a ship like this. People, again, from all over the world. How do you communicate? How do you collaborate? We all have an objective that we need to make sure we get done. Are there any other questions I might be missing here? Humanizing science. Yes, Wendy, that's what it's about. Like who we are on the ship, what we're doing. We have the passion for science. We're all super excited to be part of this tour, to be able to do some amazing things on the ship. But so it's not only contributing to science, but all of us definitely have an interest in making sure that we help other students see, maybe this is something you'd be interested in, maybe not, but just keep it in the back of your mind for the future. That's for sure. So here, I'll just give you another view of the ocean. Wish we were going to have a good sunset. I've seen some spectacular ones, but not so much today. How does the water stay out of the cone? The water does go into the cone, so it's underwater. So we don't keep the water out. We just continue to keep putting pipe down there because, again, we're interested in getting the sediment and then the core. So water does circulate through there. How much does a tour cost? A virtual tour like this costs you $0. It is for free. So the ship, as the captain mentioned, is owned by another company. So the ship is owned by a group in Norway. It's managed by the United States and funded by National Science Foundation. So in terms of broader impacts and outreach, this is part of the mission of the ship and scientific ocean drilling. So this and all the resources online, if you go to the website, joidesresolution.org, and then there's a link that's called For Educators. And if you click on that link on the main page, it's over on the right-hand column, you'll see a lot of curricular exercises that have been designed and developed that relate to the expeditions and scientific ocean drilling overall. So it's wonderful that there's also material and it's still being built and expanded upon. You can search that database as well and you can also request some cores. So they're replicas of cores because the real cores they keep in their core warehouses. So by the way, when we're done with the cores on the ship, they will go to one of 3 core repositories, either in Germany, at Texas A&M University or over in Japan. And Japan has the only other active scientific ocean drilling research vessel. So the only other boat that is similar to JOIDES Resolution is called the Chikyu. Japan owns that. It can go a little deeper than this one. And how much to fund the ship for 2 months? So I've heard quotes anywhere from 250,000 to 15 million. So it depends, I think, number of people, how far offshore you are, how deep the water you are. So there's a range of prices, but it is not cheap. That's for sure. I'm gonna switch the camera here. Oops. There we go. See a little bit of me in the water too at the same time. What's the water depth here? The water depth here, we are in just over 5,000 meters of water depth. So, and this is the deepest for the water, because again, we're gonna be transiting closer to the mid-Atlantic ridge. So it's gonna get shallower as we get closer to there. Let me see. I'm gonna try to bring up the chat here. Do I have any off days? No. There's always something to do on the ship. So, and which is, for me, is exciting. It's great. And it's kind of funny because there's some days that I'm giving 3 tours. And so I'm walking around, this moving ship that's bouncing up and down and talking to different groups. And so I have to prepare, who's my target audience, right? What are they interested in? What are they studying? What's going to make this tour relevant for them? I had a group of kindergarten students earlier in the week. The core lab, not so interested in. Clouds, yes. So, okay, let's spend a little bit more time talking about clouds and how we record cloud data when we're out at sea. So, so there's always some prep going on to be ready. Favorite place to be on the ship is outside when it's not so windy. So it's just great to be out there. Maximum depth the ship can drill. The ship can go down, it can be in 7,000 meters water depth and then still drill down an additional 2,000 meters of sediment and rock. So we've got that. Someone asked about food. Oh my gosh, the food here is amazing. I will share briefly. Every Saturday we get lava cake. We have a baker on the ship. We have a full-time baker because bread is not going to stay fresh for 2 months. So we have someone baking everything from our cookies to our muffins to our bread to some amazing desserts too. So meals are served 4 times a day. And during those times, we actually can then eat. We can also request meals too. So if we wanted scrambled eggs, didn't feel like anything else, they'll make us scrambled eggs too. I also appreciate how sensitive they are to food allergies. I have a food allergy to tomatoes, and they always make me a special meal if it's Mexican day or something like that, and they have Mexican food, or Italian night. They make sure I have something that is pesto. So, so great stuff. I know some people have to go because it's the top of the hour. What I would say is I hope you consider doing a tour with your students or follow up with me if you have any questions. You can always email the ship directly at thejoidesresolution@gmail.com. Or again, my email is gerton@psu.edu. I think there's a lot that we can show students by doing a virtual tour about the process of science, who the people are, and we can bring them some of the materials of some really cool scientific activity and discoveries that's happening in our own discipline that, again, most of them only see as a photo in chapter 1 of their textbooks.
Awesome. Thank you, Laura, so much. This has been amazing. I think everyone else is feeling the same, and they're doing lots of love in the chat. For everyone, thank you so much for joining us. I put a link, and I'll put it in there again, for the webinar evaluation. Please take a couple minutes just to tell us what you thought about this, so we can hopefully provide more content like this in the future. I will be posting the recording for this video in the next few days, and I will put all the links to the great resources and the email addresses on the website as well. So feel free to contact Laura directly or contact me, and we can get you in touch for anything that you need. So thanks again, everybody.
Thank you.